Welcome to another video of time value of money. In this video, we'll see how to find the present value of a growing annuity. Now, as we have seen in the previous videos, in case of an annuity, the cash flow is constant throughout the time frame. For example, a typical annuity will be something like this: 0, 1, 2, 3, 4. Let's say a 4-year tenure. The cash flow will be 1000, 1000, 1000, 1000. So basically, all of these are equal. However, there are situations where the cash flow may grow at a constant rate. Let's say that in order to make some extra money, you undertake a part-time job for 5 years. Your employer fixes an annual salary of rupees 1000 with the provision that you will get annual increment at the rate of 10%. So basically, your salary from the first to fifth year will look something like this. So for the first year, the salary is 1000 rupees. Now, in the second year, there will be 10% increment on the last year's salary. So basically, this will become 1000 plus 10% of 1000. Now let me take this calculation on the side here. So 1000 plus 10% of 1000. This becomes 1000 plus 10 by 100 into 1000. Now 1000 can be taken common. So 1 plus 10 by 100. So 1000 into 1 plus, this will become 0.1. 1000 into 1.1, which is equal to 1000 into 1.1, which is equal to 1100. Now in the third year, there will be 10% increment on the second year's salary. So it will be 1000 into 1.1. So this is the salary of second year multiplied by 1.1. This is the 10% on second year salary. So this is nothing but 1000 into 1.1 square, which is equal to 1210. Now for the fourth year, 10% increment on third year means 1000 into 1.1 square into 1.1. So 1000 into 1.1 cube, and this is equal to 1331. And for the fifth year, 1000 into 1.1 cube into 1.1, which is equal to 1000 into 1.1 to the power 4. This is equal to 1464. So let's represent this on the time scale. One, 2, 3, 4, and 5. At the end of the first year, the amount you are getting is 1000 rupees. At the end of second year, you're getting 1100. At the end of third year, you're getting 1210, then 1331, and then 1464. So this is known as a growing annuity. And in this case, the payments are growing at the rate of 10%. Now let's generalize this. So let's say the payment for the first year is represented as A, and the growth rate, that is 10%, is represented by G. So in case of this step here, basically we get A into 1 plus G. So in the first year, the salary is A. In the second year, the salary is A into 1 plus G. So A into 1 plus G, if G is replaced by 10 divided by 100, so this becomes 1.1. For the third year, A into 1 plus G square. Fourth year, A into 1 plus G cube. And fifth year, A into 1 plus G to the power 4. And this is A. So basically, the time scale now looks like this: 0, 1, 2, 3, 4, and 5. So A into 1 plus G, A into 1 plus G square, A into 1 plus G cube, and A into 1 plus G to the power 4. So this is the growing annuity in its generic form. Now we have to find out the present value of this growing annuity. So what is the present value? So let's say the rate of interest is I. Now the present value of the entire cash flow will be the present value of each of these cash flows added together. So PV1 plus PV2 plus PV3 and so on. So the total present value is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5. Now we know that future value is equal to present value into 1 plus I to the power n, or present value is equal to future value divided by 1 plus I to the power n. So let's substitute. So PV1 is FV1 divided by 1 plus I to the power n1 plus FV2 divided by 1 plus I to the power n2 plus FV3 divided by 1 plus I to the power n3 plus FV4 divided by 1 plus I to the power n4 plus FV5 divided by 1 plus I to the power n5. Now the future value 1 is A. So A divided by 1 plus I. N1 is 1 year for the first payment, plus FV2 is A into 1 plus G. So A into 1 plus G divided by 1 plus I, and here the periods for which this is going to be discounted is 2 years. So square plus A into 1 plus G square divided by 1 plus I cube plus A into 1 plus G cube divided by 1 plus I to the power 4 plus A into 1 plus G to the power 4 divided by 1 plus I to the power 5. So let's generalize this. So present value of a growing annuity is equal to A into 1 plus I plus A into 1 plus G divided by 1 plus I square plus A into 1 plus G square divided by 1 plus I cube and so on, plus A into 1 plus G to the power n minus 1 divided by 1 plus I to the power n. So this is the generic formula for finding out the present value of a growing annuity. However, this can become very tedious if n is like 20, 30 years and so on. So let's try to simplify this formula. So let's say that this is 1. So now in this formula, let's multiply both sides by 1 plus g divided by 1 plus I. So multiply both sides by 1 plus g divided by 1 plus I. So then we'll get present value of growing annuity into 1 plus g divided by 1 plus I is equal to, now each of these terms will be multiplied by this. So a into 1 plus g divided by 1 plus I square plus a into 1 plus g square divided by 1 plus I cube and so on, plus a into 1 plus g to the power n. So this will become 1 plus g to the power n minus 1 into 1 plus g. So 1 plus g to the power n minus 1 into 1 plus g. So this becomes 1 plus g to the power n minus 1 plus 1. This is equal to 1 plus g to the power n divided by 1 plus I to the power n plus 1. Let's say this is 2. Now let's subtract 2 from 1. So we'll subtract this from this. So this will have negative signs. So this will get cancelled with this. This will get cancelled with this. And this will get cancelled with the term before this. So then we'll get present value of a growing annuity minus this part here, present value of a growing annuity into 1 plus g divided by 1 plus I is equal to this term here. So a divided by 1 plus I minus this term here. Everything else is cancelled. So a into 1 plus g to the power n divided by 1 plus I to the power n plus 1. Let me erase this here. Or, so let's take this present value as common. So PVGA into bracket 1 minus 1 plus g divided by 1 plus I is equal to, now here let's take a divided by 1 plus I as common. So a divided by 1 plus I into bracket 1 minus 1 plus g to the power n divided by 1 plus I to the power n. Or present value of a growing annuity, let's take the LCM here as 1 plus I. So this becomes 1 plus I minus 1 minus g is equal to a divided by 1 plus I into 1 minus 1 plus g divided by 1 plus I to the power n. Or this 1 gets cancelled with this 1. Present value of growing annuity into bracket I minus g divided by 1 plus I is equal to a divided by 1 plus I into 1 minus 1 plus g divided by 1 plus I whole to the power n. Now this 1 plus I and 1 plus I will get cancelled. Or present value of a growing annuity is equal to a divided by I minus g into bracket 1 minus 1 plus g divided by 1 plus I to the power n. So this is another way of finding out the present value of a growing annuity.